This is the Unit 9 review. I made a new review that I'm going to use next year, but for students who are retaking the quiz, I felt like this was a good one to use this time. There are some notes, resources for you to use, so make sure that you get a copy of those as well. This is an open note quiz. So they want us to describe these transformations. What we have here is an absolute value function, and inside of the function, we're subtracting 7. That's telling us to go right 2. Outside of, 7. Outside of the function, we have plus 2. That's telling us to go up 2. All right, there are 3 things we need to talk about here. This pink thing is telling us to reflect across the x-axis anytime there's a negative outside of the function. The 3 is telling us to stretch by a factor of 3. And then inside of the absolute value function, when we have a plus 1, that's telling us to go left 1. Number 3, in front of the function, we have 3/4. That is a compress. The difference between whether it's compress or stretch, compress is an absolute value number between 0 and 1. But if it's greater than 1, that's a stretch. Okay, so 3/4 is between 0 and 1, so that's a compress. And then this minus 6 out there is a down 6. Okay, right here, they're giving you an absolute value equation. It's your job to find the vertex. Look inside the function, inside the absolute value marks. We want the number that's going to make, that we would plug in for x, the number we would plug in for x that would make that expression equal 0. So x plus 1, what would x have to be in order to make that equal 0? It would be negative 1. To get the second number in the vertex, we could either plug in negative 1, or we know that it is just the number sitting right there. When it's in vertex form, it's kind of clear to see. So the vertex is negative 1, negative 6. From the origin, you're going to go left 1 and down 6. 2, 3, 4, 5, 6. There it is. Okay. Now, to identify the slope, we're going to pay attention to the a value right here. This is an a value of 2, so our slope is 2. We're going to rise 2 and run 1 as we head to the right. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Okay. On the other side, the slope is going to rise 2 but left 1, so it's perfectly symmetrical about the vertex. All right. The domain on absolute value functions is negative infinity to infinity. The range, we're going to go from the low point here and then up. So the low spot happens at negative 6 to infinity. We're using a bracket here because it includes the point negative 6. We know that on the function we can get that answer. The interval increasing happens to the right of this green line. So increasing occurs from negative 1 to infinity. Oh, what am I doing? Negative 1 to infinity. And it's decreasing from, gosh, I'm having a hard time writing, from negative infinity until negative 1. The end behavior, as you look left, the function's going up. As you look right, the function's going up. So we have positive infinity in both cases. The roots are another word for the x-intercept or the solutions or the zeros. So we want to identify where the graph crosses the x-axis. So we have 1, 2, 3, negative 4, and 1, 2, 2. And we could check those. If we plug them in to the equation, we should get 0 out of it. So negative 4 plus 1 is negative 3, but the absolute value of negative 3 is 3. Times that by 2, we get 6 minus 6, that's 0. If we put in 2, 2 plus 1 is 3. Absolute value of 3 is still 3. 3 times 2 is 6. 6 minus 6 is 0, so that works. Okay, let's try another one. This one, the vertex, notice there's nothing inside of there, so what would make that equal 0? Just plain old 0 and 3. The slope is -3/4. So I'm going to rise down 3 and right 4. 1, 2, 3, 4. Down 3, right 4. Okay, so on that side it's doing that. Okay, and on the left we go down 3 and then left 4. There's our graph. Okay, domain is still -infinity to infinity. From left to right, we've got everything. The range is from -infinity, right? Stuff is happening down here all the way until we get to right there, that line. That line is at 3. So from -infinity to 3. The interval increasing, these are about the y-axis this time, so it's 0. To the left of that line, we're increasing. Right? As we approach it from this direction, you can see that the line's going up. So increasing from -infinity to 0. And then when you move past 0 and head in that direction, you can see that the function is going down. It's decreasing. 0 to infinity. The end behavior, as you look left, the function's going down. So that would be -infinity. And as you look right, the function's going down. So that's -infinity. The roots, or x-intercepts, or zeros, these are the numbers that occur there. I think in this case it's -4 and 4. If I plug in 4 for x, absolute value of 4 is still 4. 4 times -3/4, you could think of that as -12/4, which is -3, plus 3 is 0. And if I put in -4, the absolute value of that is 4, I'd get the same stuff. Next page. Okay. Again, this note page are super handy here. You want to make sure that you have the parent function graph page. This function is the reciprocal function. That looks like that. The negative, so we've got to talk about 1, 2, 3, 4 things here. The negative out front is telling us to reflect about the x-axis. The +4 on the bottom is inside the function, so that is saying to go left 4. The -3 out back is saying down 3. And the 6 up top is slightly tricky. If you take 6 times 1 over x, that equals 6 over, not 6, but 6 over x. So what we have there is the a value that's being multiplied by it. And since it's greater than 1, this is a stretch by 6. Okay, this parent function is the square root function. We're going to talk about 3/2, -2, and +1. 3/2 is our a value. It's greater than 1, so this is a stretch by 3/2, vertical stretch. The -2 inside the function is right 2, and the +1 at the end is up 1. This is a cubic parent function. -7/8 +1 -1. Okay, that negative is reflect. 7/8 is a compress because it's less than 1. Compress by 7/8. +1 inside the function is a left 1, and -1 outside the function is a down 1. This parent function is quadratic. We're going to talk about the -9 and the -3. -9 inside the function is right 9. -3 outside is down 3. I'm going over this quickly because hopefully you've already attempted this on your own. So this is just checking your work or clarifying understanding, right? So it's fast. I've already taught all of this, but this is just adding this part in. I don't know why that part doesn't transfer over with my stuff, but I'll add that in. This is the greatest integer function. Okay, so we're talking about the negative, the 4, the +5, and the +7. Negative is telling us to reflect. The 4 is a stretch. The +5 is left 5, and the +7 is up 7. Okay. Okay, then we have cubic root. Cube root. Okay, so here we need to talk about the negative, the 2/5, and the +8. Negative is reflect about the x-axis. 2/5 is less than 1, so this is compress by 2/5. And the +8 is telling us to go up 8. All right, number 12. This is a quadratic function. So we have f of x equals x squared. We've got to write the equation for if it reflects across the x-axis, so that will have a negative. Translate 12 units left, that's going to be inside the function, saying +12, and 5 up. That would look like that. So we're taking our parent function and manipulating it in all these ways. Okay, a vertical compress by a factor of 1/2 and move 8 units up. So that'll look like that. Next one, we have a parent function that is the reciprocal function. Reflect across the x-axis, so we're going to have a negative out front, and translate 10 units down. It's going to look like -10. Vertically compress by a factor of 1/4, and then translate 5 units left. That one's sort of different than what we're used to. And our parent function on this next one is the cubic. Oops, what am I doing? Equals x to the third. Okay, 3 units down, that's going to be a -3. And 2 units left inside the function, we'll add 2. Stretch by a factor of 7, then translate 9 units down. Okay, this is the square root function. Reflect across the x-axis, that's a negative. Vertical stretch by a factor of 5, -5 root x. Translate 6 units right. To go right, we're going to say -6 inside the function, and 8 units up, we'll add 8 outside the function. All right, hope those are making sense. On this last page, we're going to write an equation for the function. So what you should identify first is what type of function are we talking about. This is an absolute value function, but it's reflected, right? It's opening down, so we're going to have a negative in front of it. It has a vertex at 4, 4. So the first 4 is telling us to go right 4, the second 4 is telling us to go up 4. So that's going to look like x -4 and then +4 outside. So the -4 is telling us to go right, the +4 is telling us to go up. This is also, notice that its slope is not down 1, right 1. It's down 1, right 2. So the slope is going to be 1/2 out in front there. Okay, number 17. This parent function is the square root function. And its starting point is left 2, down 3, right? -2, -3. So that's saying left and down. Okay, so to take this left, we're going to do x +2, and then to go down 3, we'll say -3. Now let's check the slope. Look at your parent function page. Does it go 1 there, and then up 1 and 3? It does, so that we don't need any stretch or compress. Okay, 18. This looks like the cubic function, but it's headed in the opposite direction. Cubic function usually does that. This has been switched around, so we're going to say negative with this, right? Its middle spot is right there, and that's at -4, 2. So we've got to tell it to go left 4 and up 2. So that's going to look like x +4 to the third, and then +2. Now, notice on your parent function graph that the middle spot and then the next ones are 1 away from each other. But in this case, they're not. It's 2 away from each other, right? So this is being stretched by a factor of 2. Okay, 19, this is the reciprocal function. Now the spot we're looking for is exactly between these two. So usually this is at the origin, 0, 0, but in this case it's over at the spot 2, 3. So that's telling us right 2, up 3. So for this function to say right 2, we're going to say that, and then up 3 looks like this. It hasn't been reflected, and its slope seems about the same as usual, so that's it. Okay, on this, they want us to graph the following function and describe the transformation. So I'm going to, let's see, choose sort of a light color. If I were graphing the parent function, it would look like that. But this one has been shifted right 3. So what I'm going to do is take each point that I did, 1, 2, 3, and shift it over 1, 2, 3, like that. And then I'll just say right 3. Okay. 21, this is the absolute value function. Its parent function would look like this. This one is reflected, right 2, down 1. So maybe I'll use these words to describe all of that. Reflected. Right 2, down 1. Okay, so I'm going to go right 2, down 1. That's here, and it's reflected, so it's going to be opening down instead. All right, 22, this is a cubic function. I think it behaves like that and flattens out pretty good, right? Okay, so this one, they're telling us to shift left 3, down 1. So this parent function, left 3, down 1, it would be here, and then we'd have those points right around it, and that would level off quite flat. So we got to use words to describe it. This is saying left 3, down 1. Okay. Over here, looks like I have something missing. I'm going to guess that this is our, it's always missing. Okay, so this function usually looks like this, right? And it goes on this side too. So this negative out front is telling us to flip this +4, saying go left 4. This +2 is saying go up 2. So maybe let's write those words. Whoops, I'm still yellow. I don't want to be yellow anymore. Okay, reflect left 4, up 2. So left 4, up 2. That's going to be here. Now since it's reflected, I'm not going to climb up there. Instead, I'm going to go like that. We could plug in some points and make sure that it really is supposed to be like this, right? So if I put -5 in here, -5 plus 4, that's -1, times this negative, I'd get 1, plus 2, I'd have 3. So -5 at 3, that's correct. We could test a few more points too to make sure if we want. Okay, that's it for the review. Good luck. Hope things